So today what I'm going to talk about, I chose the title, Building Digital Analytics Foundation for Autonomous Factories at Western Digital. It's really a little bit catchy title, but I will talk about a lot of foundational approaches and a lot of foundations that we had to build just to even think about a distant future where we're going to enable a lot of autonomy in our factories. So the key is foundation. That's really what I wanted to point out. Today, I'm not going to talk about robotics, and I'm not going to talk about machine learning approaches, and I'm not going to go into details. I will really take a look at how we are going to build this and what are the key foundations. As Stephanie mentioned, I lead strategy and innovation and adoption in the Digital Analytics Office. The office is a global office. We're focusing on the entire Western Digital Corporation. So, as always, I have to show these slides first for legal purposes. Please read it very quickly. Means that whatever I say, it's not true. So these are really the agenda for today. I'm going to talk about our data infrastructure. Here I have a really easy job to do because Western Digital Corporation is a data company. We do produce stories. So the way I'm going to introduce our company, you always have to think about it that actually that is the technology that we are using. We are drinking our own champagne, or someone would say eating our own dog food. But we truly use our own products in our internal operations, and that is one of the key foundations for our autonomous factories. The second is data analytics organizations. Here I will talk a lot about lessons learned. I think this is the hardest part of any digital analytics movement. I think the technology is there, technology is ready, but how do you break down the silos and how do you establish a hybrid organization structure where you actually have all the business units? We at the Western Digital Corporation, we have 6 different business units where we have to collaborate and work together. So it definitely was an interesting lesson learned for us how to really establish that one, but we succeeded to establish in the end a really nice structure. We cannot really talk about data analytics without understanding what are the key secret sources behind managing data analytics project. I don't know if you ever managed, but it is definitely something that governing the impossible without boiling the ocean. Whenever we talk about technology, what's possible and what can be done, people often get carried away and they really try to boil the ocean. How do you really manage that avoiding? And last, I wish I could talk a lot more about our success stories within internally, but there are some challenges with the confidentiality. But I will try to express a lot more, and I will talk a lot more of what I have in slides too. And of course, I will sum it up and give you some final thoughts. So first, let me introduce Western Digital Corporation. Western Digital Corporation has several very well-known brands. I think the most known brands out there is a SanDisk that everybody using in their iPhone or their phones, the memory sticks. But our longest brands are itself, the Western Digital Corporation, and HGST, which is actually an IBM legacy, and you will see the history of our company. We have acquired a few interesting companies, Tegile, Up There, G Technology. G Technology is a professional storage, usually professional photographers will be using it. The company is about a 65,000 people plus company. We have a very large global presence in the US, in Europe, and in Asia. Of course, we have mostly our factories in Asia. We have 2 factories in the US, in California. We have 2 wafer factories. Then we have a few more fabs in Malaysia. Unfortunately, we are closing one down at KL, Kuala Lumpur. but we still have 2 factories in Penang. We have 2 factories in Thailand. We have 1 factory in the Philippines, 2 factories in China, and we have presence in Japan. Unfortunately, we closed our factories too. So when you look at what is Western Digital Corporation, we have the roots back to 1956. Actually, the site I am right now making our presentation is the sites where the hard disk drive was invented and first manufactured. Is the San Jose, Silicon Valley in Great Oak site. It was the first Ramac that I think maybe you have seen some images how they is being shipped. It's really size of a room almost. Then with SanDisk, we brought in a lot of, again, innovation. SanDisk, who did the unimaginable, made money on selling NAND, that in the year 2000, it looked really a brave idea. But they've grown into really technology leaders. And now, these years, we already have a 96-layer 3D NAND technology, which was the first earlier than Samsung. So when we look at, I just wanted to have these slides we usually use to see, people often talk about industrial revolutions and the Industry 4.0 and all the revolutions that are out there. This is an interesting chart in terms of what revolution really means and how multiple allocation of performances and productivity measurements can be really multiplied and really revolutionized. Think about the 1956 when the first IBM HDD came out, the Ramac, it had 5 megabytes. Now we have, in 16 we have 12, now in 18 we have 15 terabytes, which is a 2.4 million increase over the capacity. There's just, think about the technology development that has been done behind. The 5 megabytes was 50 disk, 24-inch disk. Now we can do 8 disk, 3.5 inch. The size, even the capacity has million times increased. It's the size, the surface of the data storage has decreased. The per square inch, that time they could put only 2 kilobit per square inch. Now we can put, and that's again, in 2018, we can put a terabyte. That's almost 500 million X density increase. Of course, and I think this is where our key challenge is the data rate. That's why solid state is actually winning this race. The data rate from 150 kilobyte per second has increased 12 gigabyte per second, and you can see it's not anymore a million faster. So that's something that physics does not allow us to do a lot. Of course, the power consumption is as well. And of course, the cost of megabyte, which was $10,000 per megabyte, now it become just a fraction of a cent. So that is the technology development that in the 60 years, the 6th decade, the company represents. We have several products. We would have divided platform system solutions, devices, and technologies. On top, we have client solutions, as I already mentioned, GTech and the NAS. I'm sure that if you go to Best Buy or any company, you will see Western Digital products. Then we have, of course, data center solutions. Right now, we are investing a lot of money in expanding in that area. We have ActiveScale, OpenFlex, and Tejai products for the data center solutions. And you will see this plays a lot of key role for us to establish that foundation for autonomous factories. That brands of products are critical for us, and I will explain later on. Now, in the devices, of course, we have client devices, we have the hard disk drives, solid state, we have the USB sticks, the memory sticks. We provide for phones, memories, and the data center solutions. We have very high volume capacity enterprise products. So where you will find us is truly the data centers of big internet corporations such as Facebook, Google. They do drive, fortunately, by millions of drives, and that's where our Facebook pictures are being stored. Technologies, we produce heads, wheel-drive heads. We produce media controllers, device systems, and device softwares and system softwares. And as well, right now we are working on our RISC-V architecture to enable high-speed devices. Now, when we think about data, it's the last decade has brought again a huge revolution in how we are thinking about data. When we think about earlier, we always thought about ourselves as a storage company. But truly, when you work with data, you generate, you capture and generate the data, you transform the data, and then you have provide access, and this all goes through storage. So storage often becomes somewhat a bottleneck, and the word has become truly a data-centric word. And even just if you think about the applications that you can see here, in the past, usual applications, if you look at your company's applications, ERP, MES, HR systems, and every system actually silos data together. As you can see on the left, usually an application would manage, create data. It would have a dedicated data store where it will be really stored in separated silos, and the work always is how do you bring the data together? How do you link the data together? Now, the world is going toward a data-centric view where the data itself sits in the middle, as you can see in my screen here. The data sits in the middle, and there's some redundancy, but truly the entire ecosystem and the multiple applications are truly creating, transforming, and storing this data, but it truly sits in the middle. So when you think about such approaches, earlier in the past, they were talking about terabytes of data behind ERP systems and MES systems. Now, with this new ecosystem, such as the internet corporations bring in, we are talking exabytes, which is a significant million-fold change into what's happening out there, and how do you manage these data. So our company has a concept on and introducing, besides big data, a fast data approach, because when you look at how the data is being generated, accessed, and transformed, yes, you are going to get a lot of insights, prediction, and a lot of scale in big data. But truly, when you use this data and when you access data, it going toward more on a fast data. Some people would call it edge, but we think about it more on a fast data approach between this coupling, where on the left, the big data you use more for scale and teach your models and gain insights. Here on the fast data, you use it for acting whenever you have an edge device, you provide real-time results. Even if you think about the autonomous cars, they do have to enable very quick fast data providing for smart machines, and that smart machines can be either a heavy machine equipment, or a tool on the manufacturing side, or a self-driving car out there where performance measures. So, we have built a diverse approaches and product portfolio to cover both big data and fast data. As you can see on the storage level, we truly have the HDD and SSD, the storage devices. In memory level, the different non-volatile memories where they really sit between the fast data and between the how you really transform the fast data out from those storage devices to compute, and there it comes the ASICs, the FPGA, the GPUs. How do you really provide that quickly for the fast data throughout your non-volatile memory, through the GPU, and create those fast performances? However, on the left side, it's more focusing on archiving and more capacity scale where you use more HDDs, SSD, and conventional storage SoCs. So this is really the deepest technology that I go in. Point what I want to make our company is really focusing on the entire system platforms and devices. We actually developed a really good know-how how to really design these systems, and we are trademarking a Symbiotics Design approach where we actually create data storage systems for big data and fast data together. Then, of course, this means that it's actually the know-how how we are really integrating these storage devices into achieving these. So because of that one, we at the internal operations, and that's really our digital analytics focus, we do use our own devices. As you can see on the lower part of this image, you will see an underlined and italic and as well bold, all the style that you can imagine. I just put there for our own devices. Why is it critical for us? You know, there's a lot of discussion. Are we going in the cloud? Are we going in on-premise? How do you really establish your data infrastructure so that it's really scalable? Now we use our own active scale product in both cases. And meaning that before we would go in the cloud, we do an optimization, what data needs to be stored in the cloud and what data is really relevant for those applications what run in the cloud. So on the storage layers, no matter where we are storing truly the data, we actually use our own devices, and that gives us a huge cost benefit over going purely 100% cloud. So we implement a hybrid on-premise versus cloud using our devices. For the fast data, we use our WDC Agile product to provide very quick access to a large amount of data for fast performance. And going forward in the memory, interconnect, and compute, it's really depend on which platform you are. If you think about, we are collaborating with AWS, we store our cloud data, and cloud provider is AWS, and we're using their stack there. But in-house, we are built bare metal servers for on-premise databases, where we use Mesosphere, VMware, and virtual OSs to provide fast data track, and that's on-premise. So every in our plan, and every of our factory will have on the edge a very large on-premise. And the good thing in between that the top layers through HDFS actually is very seamless. So the user will not even know, is it running in cloud or on-premise? So we will be able to create a layer where the user will not know. So that's all I wanted to talk about technology. I wanted to introduce our company. I wanted to say that you know, we have a various storage products. Actually, we are one of the leaders out there in terms of storage. There are not many companies left who produce HDDs, Toshiba, Seagate, and us. And I think our product is really superior to over there. The good thing here is because we are experts in data storage, our internal operation is very lucky. We can leverage on that, and we can use our own technology to establish that platform for the future. And as I said, every of our factory will have a very large on-premise data storage. We have now 3 out there, and we are experimenting with it. And that's really the future roadmap for establishing that data infrastructure. Now, in the all technology discussion and all high level, you know, high tech is apart, we have people. So when we think about enabling AI and autonomous capabilities at our factories, one of our key challenge was organization. And I just want to put a few slides and I will explain, and these are explaining our thoughts behind it. I can't really much write it down publicly, but what's happening is that, or what happened in 2006 is that we started on the fast data and all the roadmap and all the discussions that I was talking about using our own products and revolutionizing our own internal operations started around 2016. So our SVP of the business unit I worked for that time, it was asked, okay, what are we doing about analytics? How are we going to revolutionize our internal operation? And I was lucky enough to get that job and say, get assigned, Attila, go and figure. So one of the key, what I have seen is that people were really thinking about that the big elephant in the room is, okay, we have invested millions of dollars. Where is the ROI? What is it? We're still running our factories in Excel sheet. Where we want to go? It's just not, you know, it's there, but we have not utilized it very well. Okay, that was really the general, let's say, the management input that I get. Then of course I get to the silos down, and I started to talk to them about that we are, you know, what are we doing about analytics? What else could be done? And, you know, we are going to go out with this really nice internal infrastructure. Of course, you know, are you reinventing the wheel? I mean, they told me, Attila, we already done this. We already know this. All the silos were very confident, very comfortable. You know, they are doing their best, and just don't bother us, right? So thinking about a 30,000 people business unit, and you know, I met a lot of people around. I was really a little bit challenged because at one point you see that you know, everybody says about you know, it's not worth investing. You know, we have invested, we lost a lot of money on this. It's nothing. But when you talk to the experts, then they say, oh, come on, we have done all this. Then what else you can do? What is it that's really why we can say that we are truly an analytics enabled company and operations, why the perception is not there. So when you look at this, the reason what I found and the logic I was following is that truly data science is a multidisciplinary science. You can't really say that, you know, it's just math or it's physics or economics, or you can't really just say it supports a lot of different, even finance, procurement. Data science can support the entire organization, and there is not one, you know, heroic organization that will bring this down. This is multidisciplinary. We need to think about it as it's actually, you know, webs around every part of the organization, and we need to think about it differently. Now, the other area that I was thinking about, and it always bothered me a little bit, that we think about Industry 4.0. In 1996, I was in a world biggest Audi factory in Europe. I'm originally from Europe, Hungary. And they built this beautiful factory. 1996, they already have a lot of robots out there. They already automated the factory. And I was thinking, okay, we're talking about Industry 4.0, but what does it really mean for us? Where to go next when you have so much automation already on the floor? Now that's what made me think that industrial engineers have done a great job automating our factories. And I think from the technology point of view, if you want to create a fully automated light-up factory, it's not really a problem. We do have a light-up factory with Toshiba in Yokkaichi in Japan, and we also have in Shanghai. Now the problem comes that you generate so much engineering work that actually the automation goes and the labor work goes into engineers, and you start to hire hundreds of technicians and hundreds of engineers just to run the factory. So I was assuming that, okay, if an industrial engineer automates factories, that, well, data scientists need to automate engineering departments. Meaning, and we had a little funny discussion about, oh, does it mean that now we are working light of engineering department, and you know, it becomes LED, which is a lot of fun. So truly, if you think about, that's what's happening. Data scientists are out there to automate a lot of human work that is more maniac rather than you know, physical workforce. Now, And definitely, we had to figure out a way to break silos, and we have to embrace collaboration in some way. I think this has been a usual, way companies think about it. We always have to teamwork. We always have to collaborate, break down the silos. But you will see, I figured out here a really interesting approach, and that's what's the lesson learned, and it worked. And truly, what we convinced ourselves, and I could really get back that if it's really well done, if it's done right, data analytics can truly be the silver bullet and deliver a multifold performance improvements over what we do. So the first interesting thing I introduced is network organizations. I had a really good friend that I met in one conference, Rob Cross from Babson College. He's a professor who's been, who's been researching networks within organizations, corporate structure, and he had a really nice presentation. And what I was telling the silos that, hey guys, please don't think about as you need to have a dedicated organization. It's all about collaboration. We can be an organization without reporting to each other. It does not really matter where are you from the hierarchy, which sounds utopic, but I did sell this. It doesn't matter, we have diverse talents, especially in data science, and we have very specialized skills. Many of these key analytics leaders, they have a key proven track of records and success, and they have developed leadership and people skills around. So what if we really put them into a network, and what if we really start to have them collaborate, sharing goals, sharing information, which was a big thing. And the other leverage resources and learning. There have been a lot of redundancy within our, and it was a big business unit, 30,000 people at our head in media. There were a lot of redundancy. They could really easily leverage resources and learning once they learned about, hey, in Penang, in Malaysia, we have done already this, and then now you can leverage that in Shanghai or in Shenzhen, or you can work. So once we build this network and we enforce them to share and collaborate, there was a lot of good consensus and alignment. And as well, I told them that, hey guys, we can make decisions. We don't have to be one organization. If every one of you votes and we have a decision-making framework and we can get consensus on goals and patterns and actions, we can actually deliver. And of course, we could act as one organization. We could improve quality and productivity. We accelerated a lot of projects. So what happened is that how it's all started in 2016, I had the same slides, network organization for about 100 people across worldwide. So I invited them. That time I was not even a director. I think I was just a manager down there. And I was inviting senior directors and directors. And I told them the story about the networks. I told them the story about our SVP giving me the task to look at this. And I told, let's try to figure this out. So we did a 3 days workshop, and I told them the network idea. I told them, no matter where you are from the hierarchy, it doesn't matter. We just really want to make it successful. And we created visions, we had a really well engineered and designed workshop to go over our SWOT analysis, review the projects. And as you can see, there was a lot of four-wall works, a lot of post-it, a lot of sticky notes, a lot of interaction, a lot of discussion. We reviewed all 84 data analytics projects. We discussed collaboration activities. We reviewed our data systems. We figured that everybody using different tools, they swear for different, one is SAS, one is Tableau, one is Spotfire. We have all across the board and the software tools. Then what we were really establishing that our key focus engineering productivity. As I said, if industrial engineers really try to automate shop floors, data scientists and data analytics organization, they have to focus on improving engineering productivity, trying to do more with less. And I think that was a very well done statement, and the entire leadership team was very excited about working on how they can really eliminate engineering workloads and how they can accelerate and give them more time to focus on more value-add activities. So we created an operating model throughout the mission. We created a vision, and we created a playbook. Our company is a playbook-driven company. I have not seen this in organization development yet. I'm not even sure I can share, but later on I will talk to legal about this. This is our playbook. Every organization creates a playbook that actually has a strategic anchors. As you can see, for our data analytics network organization, but as I said, we acted as one organization. It's really optimization, collaboration, culture of high performance, efficiency, effectiveness, and it's all focused toward engineering productivity. We established immediate imperatives with goals and with discussion, and of course the vision: create a data-driven culture where we enable and accelerate business decisions based on sound statistical principles by fostering analytics, innovation, and revealing opportunities. You know, once you put these slides up together and you go back to the senior VP level and even C-level, and they see that you're using the same format that we would be using for any other organization. They are, you know, goals, they are true imperatives, and follow through you can through this project. It's been really accepted. So the network organization was a very big success. It went up to our CEO. We invited Rob. We are key partnering, and now we are, once you look at Rob Cross on the internet, you will see that there's a really interesting studies on organization development. How do you use personal networks and how do you map out networks of people? And since then, it's actually HR adopted, and we already, you know, using this approach on several other transformation ideas. Now, one thing was, which was really interesting, how do we get feedback? You know, data analytics organizations. So out of these 100 people, I had weekly meetings and I have different, you know, discussions. So the very beginning, we always, every meeting and every time we met, we always gathered data. And we asked, okay, so rate this meeting 1, if you rather stay at home and the meeting was totally useless, it's just not really worth, and rate it 7 if you would cancel even a Hawaiian vacation for this meeting. So we, every time, nobody said that, by the way. So that was the most impossible thing to say. So as you can see that at the beginning, there was a lot of resistance. We had a little, you know, 4.5, somewhat, you know, over the median, but we still had a lot of, then, you know, we had to start a strategy formation. Actually, it was a lot of process, and that brought up to 6 at one point. And then when I introduced network organization, then like everybody, like, what is this? What, you know, how it's gonna work? Then we went through the workshop, and in the end, we created a final package, and the final package had to be voted by all 100 people, and we get the majority to go back to the executives, and we actually created a really nice proposal. And at that point, we achieved again 6. So it's an interesting, fun tool when you work with big organizations. They are not really reporting to you, and you try to break down the silos. This was a very interesting tool for us to actually understand, and it was a lot more because we gathered information. Fast forward 2018, throughout all this organization, we did not start that we need a dedicated organization. In 2016, we already knew we need to, but it took around 2 years for us to actually get to there. These network organizations, the roles and responsibilities so significantly, and the results were so tangible that we could go back to our executive team and we could actually establish a dedicated organization. That became the Digital Analytics Office. In the Digital Analytics Office, we have 4 key pillars and organization: the strategy, innovation, adoption. That's taken by me. I lead that one. We have a data analytics engineering. That's truly the data science organization. We have analytics business partners. They are truly our negotiators and understanding what's happening out there, understanding what are the business objectives. And as well, we have special projects, the existing sustaining and transformation projects that we do that a special project department. So that's what I wanted to a little bit talk about, that there was a lot of lesson learned in terms of how do you get aligned in a, 60, 70,000 people organization. How do you make them collaborate? How do you make them believe that something is possible? We really went through the network organization was a great success. We delivered a lot of good projects. Now, the next one was that was really hard for me is to implement project management. Data analytics projects were usually ad hoc. They were come and go, and a lot of failures, or very long, multi-years projects and not going anywhere, a lot of spends. So we discussed that we created, and that's my trademark. I didn't put a TM there, but innovation machine. So we decided that let's think about there, several different people in our organization. We established a group who were more architects, with people who are very high skilled in storage platform, people who are really high skilled in establishing processes and design and develop processes, and as well best practices on the software area. So those are the groups that we think about them more of architects. Now, when we think about passionate people bringing in transformation and change, we call them guardians. And we established like guardians of innovation, guardians of business focus, guardians of discipline. And depending on where the idea and the initiative is, the task and review and we relied on these groups and type of people to work with us to vet out ideas. So one of the key is that usually throughout the analytics community, you're receiving a lot of great ideas. You're receiving, we can change the word, or this is this new machine learning algorithm and we could use for this and that. So actually you bombarded, if you have a good analytics community, such as when we brought up the network, we have hackathons and we have boot camps and we have conferences, AI conferences. So we have a lot of discussions about data analytics and data itself. And throughout those activities, we receive a lot of initiatives. And that's really the strategy and innovation is that's what I really own now at the company. We have all these initiatives, but we have to vet this out. I mean, you can't really go and run everything. I mean, we really need to think about a POC approach, right? So we have a lot of passionate people who are ready for, guard innovation, and they're ready to go out, and we discussed, okay, so let's go about, you have an idea, right? So let's, map out the data, let's get the data, let's see whether we can create a use case, whether we can isolate certain data sets. Let's talk about, sometimes is it a no free lunch? I mean, when you don't collect the data, when you don't have the data, when you can't have, then truly you will not have any insights. Or so the subject matter of experts review whether the data truly represents and really relevant. And then as well, the best practices, what is the best statistical analysis to go about algorithms, and then we created a proof of concept. And if the proof of concept was not successful, and we are setting about a 20% target, meaning out of 10, if only 2 ideas work, that's fine, right? So we enable a quick, fail, fast approach, meaning we don't mind if an idea is scrapped. That's okay, that's perfectly fine. You don't have to push forward. If something is not working, do not think of it as a must-do item. Drop it and announce failure. That's okay. I mean, that's again, in a big organization and an IBM legacy organization, that's something that is not not looked well. But the key was that we did not invest any money, right? So we have a very small proof of concept just to see the technology, so just to give the ideas a leg. It usually does not cost anything. So you can do it without almost any major cost. I don't know, if you use consultants maybe about 100 or 200K, but you can, if you have your own people, then actually you don't need any capital or almost expenses to do this. Now, once you get out the ideas, the next is their business focus. And that's most important, right? Because sometimes these ideas are great and maybe a POC works, but when you look at, 2 people versus 2,000 people, the scale ability might be an issue. And as well, do you have the infrastructure that can provide you the latency, the fast data, right? Can you really scale it? You have to think about that. The next one is that usually if you implement a new analytics approach and you have a new tool, you have to redesign your business process. There is no way you can stay with the same business process as before. So you really need to think what changes need to be done at the business process level. And as well, when we think about a machine learning algorithm where you need to continuously train some data, what kind of solution specs and designs you need. And now you are at the business project level, right? So now you actually established, you think that you can scale it out, you will have the right infrastructure, you already have a good idea what the business process is gonna look like, how the solution design gonna look like. Now you can create a business project plan and you can say, okay, I approve. Here, we again did about, let's say the 80-20 rule. Out of 10 ideas or out of 10 POCs, that's again the success rate only 20% of the 10. So out of a lot of good ideas, if 20% is says we can do it, it doesn't make financial sense to scale out that idea, then we drop. But we would expect many of the ideas will have legs because the POC is well done. Then you do the business integration. Now you work with the guardians of business discipline. We have implemented so many systems before that after a few years, people drop because there is no true business integration into it. So follow through, usually not the strength of data analytics projects and people. So you really have to follow through, integrate into the business, create that data dictionary, make sure that the data is being well managed, make sure that the business process makes sense and implemented, and change management around it is documentations, of course, and manuals, and then you succeed with business transformation, and hopefully you really create that business solution out of that spark that came from the analytics community. So this business process, we have implemented it and we have had success. Actually, in 2017, we implemented our very first artificial intelligence solution in our Philippine factory, in the factory in our Philippines, and we had our very first implementation. That was really nice. It came through to this project. We actually used this process to drive it. Now, another area that I want to talk about, and I think this is brand new for us a little bit, we started to work on this year. We often struggle with ideas and discussions and systems when the proposal comes, then people usually tend to try to solve everything. And we can't. And I think the greatest example is the self-driving car out of Tesla announcing that we are going to soon have fully autonomous cars. But then the rest of the companies, they started to think, wait a sec, I mean, there must be some levels. And I don't know if you're familiar with the self-driving cars. Autonomy is level 1 to level 5. Right now my Honda Odyssey has a level 3. Actually, it works really nice. So I see what the other companies do. They're more strategic on how do you really implement and how do you augment. And I think augmentation is a critical word there. And I'm finding that a lot of colleagues from different industries and how I communicate with them, we do believe more in augmentation. Meaning that when you think about how do you really apply AI in a factories is more augmenting. So on that note, we started to think about, we established, okay, so when we think about an idea that creates an autonomy at the factory, We discussed there is a a process in focus where usually you have a process and a test, and then you have upstream processes, downstream processes. Then in the end you have final test, and you have the field. Your product is out the field, and you can collect data about it. So the very first level, we create this test data base where we just really enable defect classification and anomaly detection, right? So the very first level is that can we really not, let's say a visual inspection or any inspection area, can we use an image recognition software that would classify defects and that would analyze anomalies? You will see it's a huge implications because we collect so much test data that actually humanly we are absolutely impossible to look at. We look at fraction of the entire test data that we collect throughout, the magnetics and memory. Of course, we have terabytes of data in one of our devices can be stored and every bit to be checked. So this was really the level one. Okay, when someone come an idea, what is it that you want to do? Oh, you just would like to have the test data, teach a classification and classify it. Of course, this is productivity improvement on the floor because now you don't need technicians to look at those images or the test data. Now the second was, I think you also deal with, our industry deals with too. We run a lot of tests, so much tests that our CapEx is actually our capital investment going away on a lot of tests. So there is a lot of push for reduce the sample rate, but reduce the sample rate reasonably and make sure that it does not impact the quality of the product. So when you talk about the second level, we established a myopic sample rate, meaning that if you haven't seen this defect too often, then now maybe you can reduce your sample rate, and then what is the statistically probability that you have you will impact quality with this reduced sample rate. So that's really we thought about the level 2. In level 3 is more dynamic sample rate, meaning maybe you can go sometimes audit, maybe you can reuse. If you don't see anything critical from the upstream and the process data, then you can dynamically reduce your sample rate or increase your sample rate. If you see that the process might be shifting, maybe you go full sample rate, the highest you enable. Or if you see that everything is really stable and you haven't seen any dynamic changes, then you go back to an audit. So these systems we already have in place in our factories, where we actually dynamically adjust the sample rate based on what we see happening in the upstream and the processes and previous test data. That's what we think level 3. Now in level 4, which often called the advanced process control APC approaches, where you really gather data from your process, from your test, and dynamically adjust process parameters. Let's say if we etch something and we have clear measurement about the etch rate changes, and of course at the measurement we can see, and then later on I will talk a little more about how it works, but can you really intervene into the process and change process parameters so that you have a high test result? Now the last level 5 is more in the dynamic spec. We are often ask ourselves, are we measuring the right thing? Is it really what matters out there? So you collect data and you correlate to the final test, the field data, the process data, and you try to adjust your specs, and that be process design, test specs for truly meeting those final test and field requirements. So that's really and another tool that we use to understand ourselves, an idea or an approach, where it belongs, how much complexity it has. And usually we do level 1 to level 5 to go around. So now the last topic that I want to talk about is more success stories and the summary and how we have AI at work in our companies. So one of a key business unit, and I just brought this up because I think it can be represented very well, the complexity. We fabricate, as you can see in the right upper place, the HDD has little tiny read-write heads that read and write bits from the disk, and to produce that head. And you can see in a little on a dime, you can see how little tiny those microprocessors are. It's a very unique microprocessor. Is not really truly like a CPU or a GPU will be. We not working with transistors. We work with magnetics and shapes and forms. So it's a really fun thing to manufacture. But sometimes, and right now we are almost 2,000 steps. It's about 4 months to produce one of those little things down there. And it's an extremely high number of operations. Of course, the 2000 is not, I can't really write it down, but we have a lot of, one of these wafers, they travel miles and miles throughout our manufacturing sites just to get manufacturers. As I said, we create shapes and not transistors so that we can provide these magnetic properties. The functional geometries are smaller than 20 nanometers. And we create layers, atomic layers, 3-4 atoms thick materials. And there's a little picture on this one. So in this manufacturing, think about it. We have about 2,000 steps. 30% of the steps is imaging. And what we used and what we created is that we produce 80% of our test data in wafer is images. Some images we can't really look at. We produce even temporary images. We produce millions of images across. We have about 2,000 steps, about 600 is inspection, and we create various inspection images that we cannot really take a look. Often happens that I mean, fortunate enough from the field, but from the final test or from our HDD assembly, we often get that, oh, this component, doesn't work. Then usually what we found, we go back, trace back, you look at the images, oh yes, there was, an edge out, and then you can isolate now the batches, and then you have to create that. But sometimes it does happen from the field, and that is a tragedy for us, meaning that, we through our hand, components slept through that actually caused a quality issues. And I know in the medical industry, it's also a very critical area. You can't really have field failures, and the quality has to be protected. So our vision was, we have these million images, can we really create a deep learning approach where we enable to look at every images and guard our quality and make sure that every product that we component that we supply for our hard disk drive is correct. So we created this. Actually, we worked together with Google, and we created this deep learning approach. It's a convolutional based on the Inception version 3, and we started to teach for every operations and unsupervised classifications, and of course getting the defects and anomalies out. And now many of our images, and we are ramping this capability up. We implemented only yet into the most important operations. You have to collaborate somewhat with NVIDIA because they have the right technology to do this, the hardware technology. And you run through, and then you actually create a model library, and you create a fast image processing. And this is on the left, you would see that's the big data platform. On the right is more on the fast data platform where you run this image processing, and we can automatically evaluate defects and issues on the line. This is a major breakthrough for us. This is the first true big AI implementations we have done. The first one was in Philippines, as I said, last year. But this year, this was a true breakthrough for us. And it has a lot of promise because we can go throughout the levels. As you can see, this is still level 1, but it enables a lot of good areas. So closing my presentation, it's time, it's 6:48. Oh, I'm sorry, 9:48. So closing my presentation, how do we get autonomous factories? I chose this. You definitely need to think about the foundations. You really need to have enable think big. You enable data analytics organization, you promote this innovation, and you make sure that people are enabled to think progressively and they can interlock and exchange ideas. You always start small, make sure that you do POCs first, you create lags, you vet out and validate that everything is really great, and you involve SMEs. You can't do this without engineers. There is nothing worse than, you know, and then I even wrote suicidal for a project that just try to do everything, you know, doesn't really understand what level of autonomy you would like to enable. It's all over the place, causing a lot of more work for the SMEs. So start small, do not disrupt at the beginning, make sure that the idea has a lot of legs throughout your organization is different. The adoption will be not as easy as for the internet corporations when they do something. And the last one is scale fast. Actually, I came out the scale fast earlier than McKinsey, but I've seen McKinsey already using it. Not that I would claim but you really have to think about and establish an end-to-end infrastructure where you can implement these POCs and quickly ramp up and scale up. Many times, POC is successful. After that, the infrastructure is not well chosen, and it actually becomes a silo. Overall, you know, we have 11 plants where we use this. We already counted 1,000 different applications based on the wrong scaling ideas and wrong scaling systems. So you really need to make sure that you have this infrastructure that enables a very seamless scalability, and then implement new ideas. We believe that the technology that I showed you on the big data and the fast data can provide us with the scale fast data infrastructure. And last one that usually people like to think about and like to talk about AI, should we be scared? Now, I always have a story for that. I believe the Industry 4.0 or the whole fourth industrial revolution started in 1997, and I clearly remember the day, May 11, when Deep Blue defeated Garry Kasparov. It was big news. You must remember that. And what's interesting that nobody or not many people talk about it and knows that fact, the Deep Blue actually made surprised Kasparov by a software bug. The surprise that came through to Kasparov was a software bug. And Kasparov saw that the step is either the brilliance of, you know, super intelligence. He couldn't really believe, and actually the reason he lost the game is because he couldn't really decide, is it the brilliance of super intelligence, is it really true or not? But in the end, actually, that was a software bug that happened. So we can say that Garry Kasparov, who was the first victim and publicly humiliated by AI, said the following: what about looking for a positive side? Now we have new intelligent machines, and they will be taking over, I would say, many other aspects of cognition. So maybe it will help us to elevate our lives toward curiosity, creativity, beauty, joy. So there are other things that we can do if we move to the next level of the development of our civilization. So that's, I always answer, shall we be scared? Well, maybe there is a positive side of it. Maybe we can turn this to our side and we can elevate our life. Right, thank you for listening. I talked about an hour more. Thank you very much for your attention. And Stephanie, thank you very much.
Yes, thank you. Maybe one or two questions. Everyone has a question or say speak up, then
I still have time. It's I need to teach at the elementary school at 7:30, so I still have some time. I teach kids programming in the morning.
Oh, fun.
So is there time for a question?
Yeah.
Okay.
What?
So Attila.
Yes.
A question in terms of I think some of the things that you were mentioning with regards to, you know, your automation. I think even now with your talk on, you know, the 4 tiers on your sampling rate around on that piece, because I think there's, from at least an FDA standpoint, there's maybe a parallel, right, where we can learn in terms of engaging with the way we kind of oversee the med device industry. But I'm curious to find out, was that something that is enabled simply because you guys had so much information, so much data, and were able to characterize it, or are you able to kind of leverage that model, that thinking with a lot smaller sample?
So to create a great infrastructure where you actually have access to a large amount of data and you democratize the data was very critical. So definitely we have to establish a good infrastructure where you provide access to data. But I think just breaking down the silos and talk about ideas was the most important part, because no matter, you know, once you store the data, and maybe it's not in a fancy cloud platform, or maybe it is in just you know, some servers around, you can start integrating that one. So once you actually collect the data and you store somewhere, and that somewhere has somewhat an accessibility, then and democratize access through the organization, that's a good start, because you don't really need, for vetting out ideas and looking at it, you don't really need large scalable data infrastructure. Of course, for the production implementation, you definitely need, you will be, once you start to scale, but with the POC, with the good thinking, and with a good team, you can establish a really high ROI. And once the ROI is there, it becomes a business project, and it drives toward. So that's our view. Ideas are easily come and go, but vetting them out and making sure that they truly can help an organization is critical. Getting buy-ins throughout different, as you have seen that I talked about, the innovation machine, that we have different groups of people and how they vet out an idea, and by themselves they get convinced that this is a good idea, was a key part of our success. If people receive an idea and they are authorized to vet it out and stand behind it throughout that innovation process that discussed, was the most important is that now you have the entire organization to buy in for a change. Change is hard, and that's what's the change management is very going to deal with, rather than the data. Once you collect the data and you can create the data, or you know, store the data somewhere, to you know, get it out from any systems is just some data engineering job that can be done by a lot of people.
So Attila, has Western Digital put any level 4 processes in place, or level 4 use of data?
May I have the question again? So any processes where we use the,
where you're using the dynamic process parameters?
Yes, actually we have been implementing our APC, that Advanced Process Control Systems. They are not really based on machine learning or deep learning approaches. They are based on engineering models, hard-coded engineering models. There are vendors providing APC. If you look at APC as it is, Advanced Process Control, you will find providers. We worked with Inficon or Rudolph Technologies, and we actually use the dynamic process parameters adjustments. But again, it's not, the model is not a machine learning model, is not too adaptive. You really need to have an engineering model. Once you have an engineering model, let's say, for example, adjusting an edge rate or adjusting some chemical compositions, adding more, you know, let's say if you have these plating processes where you have a bath of chemicals, and you have to make sure that it has a certain property, we can actually automatically adjust based on what we see at test. Or when we see in a methodology, we measure a layer thickness, and now we can calculate the etch rate based on how much the process time, and we can adjust the process time and the recipe. So yes, we have a level 4. We do level 5 in terms, right? I mean, that's also an engineering work, meaning that you understand how your product is performing at the final test in the field, and you adjust your specs and you understand what, but it's not automated, right? So when we talk about the levels, we're talking about automated systems that would help engineering and augment engineering work in that area.
Did you need to get customer agreement?
Yes, definitely. We have a very strong, actually, funny thing that people will think about qualification being a gate for getting AI done. For me, it was actually the enabler because what happened is that we have very strict qualification processes, as you do most probably too, where you have to let the customer, depending on the change, you have to let the customer know, and the approval by the customer. And you have this very massive qualification processes that might even take 3 months, 4 months because of our cycle time being that long. So we have qualification processes. You can't really change a recipe without the customer knowing it. So you have to let the customer know in many cases. Now, what was interesting when very first time when we implemented the first, and that was a level 3, the dynamic sampling rate, because we kicked in audits sometimes when we see that the data is very stable. So we wanted to go to audit. We skip test, right? And that was a major, kickback from the quality organization for us that, we cannot do it. And what we have done is that we use the usual qualification process to qualify the product itself. And we went through. So the qualification process itself helped us to prove that the idea is good and the system is ready for production readiness. And that's what we did. Even the system, when we first put this, even VP and SVP level were saying it's not possible. This is insane idea. And we just said, okay, let us try to qualify. And we could go through the qualification, and we had a really great result. So it actually slows down your process, the qualification, but as well, you have to make sure that you have a good product. So that's within our ideas too.
Attila, do you conspicuously measure your total cost of quality along the way? So as you're making modifications, are you actually looking at the reduction in appraisal and failure costs?
Yes, we have a very serious warranty. So think about a customer like, let's say, Amazon, who is really storing their customer data. And there can be even 99.999% chance that they lose the customer data. So we have very serious warranty agreements, and we have I don't know if that open or not, but about 2% of our revenue going away for warranty. So it's a very significant amount. So what we have to make sure that the customer gets a good quality product, and we liable for any product failure. Actually, 2 years ago we had that's an interesting story. What happened in our factory that a type of drive started to fail in our customers. Of course, it was a huge critical situation. Actually, we have in our data analytics organization a critical situation when drop everything and solve this problem because the customer is being impacted. And we had to really look at a type of drives that were failing. Throughout the analysis and all the data gathering, what happened is that an air conditioning system was, half a year ago down in our Shenzhen factory, and that caused one of our spotter tool to shift, and it produced a batch of bad products. So of course it was a huge warranty issue, and we had to apologize, and of course paid a lot of money to the customer. So yes, we deal with high cost of warranty and cost of quality models. We quarterly monitor cost of quality. We have a cost of quality model that we have developed with one of big consulting company. And actually, I am as well working on financial models, not just only the cost of quality, but as well for our factory automation as well.
All right. Well, thank you again. We appreciate you joining us early online, so appreciate that, and we'll let you go teach your elementary school kids now.
I thank you very much for the opportunity, and then thank you meeting you all virtually. So have a nice day, and I'm really sorry I couldn't be there.
Thank you.